Okay, great. So welcome to another OpenZFS office hours. Our host today is Justin Gibbs. It's been a long time since the previous office hours, I think about a year or so. So we have thanks to Linda Cately for organizing this and setting it up. So let's go ahead and get started. Justin, why don't you introduce yourself and tell us about how you came to be involved with OpenZFS?
Sure. So I'm Justin Gibbs. I work on petabyte scale object storage systems for SpectralLogic. And my introduction to OpenZFS came through FreeBSD. FreeBSD has had ZFS support since sometime in 2007. And SpectralLogic basically was operating using OpenSolaris for doing its storage, object storage based products. And at the time that the Oracle acquisition occurred for Sun, SpectralLogic decided to switch to FreeBSD. And that's really when I became involved with trying to convert their existing product over from OpenSolaris to FreeBSD, just because there was some concern about what the trajectory was going to be of OpenSolaris with the change with the Oracle acquisition. So the rest of my background is mostly FreeBSD based. I've been hacking on FreeBSD since 1993 when FreeBSD really started, and mostly on the storage side, SCSI subsystem, some virtualization, file systems. So that's mostly what I've done.
Cool. So I'll start off by opening this up to anyone who has questions for Justin. I also have some questions for him that I'll throw in if you guys are feeling shy, but if anyone has a question to start us off, go ahead, unmute yourself, or on IRC, just spit it out in the OpenZFS channel, and I'll relay it to Justin. Okay. While people are thinking of questions, maybe I'll ask you one. So, what do you think? So let me start off with the easy one. Why did you start using OpenZFS in your workplace? Were you involved with that decision, or did somebody make that decision before you? And why did they decide to use ZFS as opposed to some other storage technology?
Yeah, so the initial decision to use ZFS happened before I came to SpectralLogic, and that product was really envisioned as a fusion of virtualization, virtualized storage, and the ability to do all the things that ZFS already had really gave them a leg up in trying to do that. So being able to do snapshots and create zvols and things like that. So the original plan was essentially to provide just about anything that you could want in a storage appliance. A very ambitious goal. In fact, Ken Murray, one of my coworkers, talks about it as the Swiss Army knife of storage systems, right? So you could do NAS, and you could do, so that's, SMP and NFS and all that kind of stuff, and have file systems just for that. Or you could partition off zvols and launch virtual instances. SpectralLogic works primarily in the M&E business, and so a lot of times those software packages want to run on Windows. So how could you actually run those in the box instead of having to have separate machines? So actually, when I started at SpectralLogic, a lot of the focus was just on virtualization, how to get Zen to work with FreeBSD and have high enough performance when all the storage is backed by ZFS and zvols. Mm-hmm. So a lot of pain and a lot of learning about how things like NTFS work, especially when you're going through a tiny straw, with all the virtualization penalties of trying to get those requests all the way back to a ZFS volume that's running on FreeBSD.
Cool.
So a lot of my initial interest in optimizing and tuning ZFS come from that perspective. Our goals have changed since then, so more of it is on object storage, not virtualized storage. Mm-hmm. But still, some of that initial work with ZFS kind of colors my focus on ZFS.
Cool. So it sounds like it's really the versatility of ZFS that initially was the initial driver there in terms of being able to do whatever you want.
Well, that
even if production changes.
The other aspect of it so there was the requirements for
Mm-hmm.
sure that ZFS satisfied, but I think a lot of it was also pushed by being burned in the past by hardware RAID cards.
Mm.
So there were issues with firmware bugs in an Adaptec RAID card that they were using. And of course, the vendor was unable to replicate the issues they were running into. They had no visibility into the firmware. And so the CTO at the time basically said, I want to control everything. So if there's a bug, I can fix it. And so the product as it stands right now, apart from the machine BIOS and some bits of firmware that's in the expanders of our SAS backplanes, we pretty much have access to everything, source code for everything.
Cool. Yeah, I like that kind of engineering.
Yeah.
So we have a couple of good questions on IRC. The first one's kind of related to your talk about virtualization. So Alan Jude is asking if there's any best practices essentially for running ZFS on top of ZFS. So for example, running a virtualized environment where you have ZFS as the running in the hypervisor essentially, and then also running ZFS inside of the guest VMs. Do you have any tips or best practices for how to get best performance there?
Yeah. So as it stands today, the best choice is to create an underlying ZFS file system with the smallest record size that you can tolerate, because the virtualized environment doesn't really understand or doesn't deal very well with usually having large record sizes. There is some outstanding work that I've been trying to push up into OpenZFS and eventually into FreeBSD that allows some more flexibility in choosing the underlying record size by making sure that when we do writes that are not aligned to a record size or aren't a multiple of a record size, that the guest doesn't block while we're doing that read, modify, write operation. But in general, the long-term best practice, I think, at least this was the conclusion that we kind of came to at Spectral Logic, is that the more visibility you can give to the underlying guest, or I guess it's not underlying, right?
The overlying guest.
Yeah. So the guest above you about the underlying storage, the better off you are.
Yeah.
And so we were exploring actually some virtualized file system drivers that were basically just forwarding the operations directly to the underlying storage. And I think that eventually when we get... What's that?
Virtualizing the file system rather than virtualizing the disk?
Yes.
Okay, cool. So like you kind of have like a NFS type layer between the guest and the host rather than a iSCSI-like layer.
Yeah. So understanding that the transport between the guest and the underlying storage is reliable, so you can make some optimizations there. But also if you could basically say, well, this really is ZFS, you can do the things that you would do with ZFS, might actually make it a lot easier for the guest. Like you want to create a snapshot or whatever. There are other ways to do that, like as you said with iSCSI and those types of protocols. But the fact that you're not talking really directly to what you're really landing on becomes problematic and does have some costs.
Cool. We have a request that you tilt your camera down a little bit so that your head is further up on the screen, so that yeah, cool. Thanks. Oh, we can also see your cool EuroBSDCon shirt. I think
I'm
the
actually...
little icons go across the bottom. So.
Oh, I see. So I'm actually wearing this out of respect for Paul Schenkenveld, who just recently passed away. Some of you may know about this. This conference, actually, EuroBSD 2011, was the first EuroBSDCon that I had the pleasure to attend. He made this event happen and basically is responsible for the continued success of the EuroBSDCon conferences, and so he will be sorely missed.
Absolutely. And I think there's no greater honor in the engineering circles than to have the things that you've created outlive yourself. So certainly quite an accomplishment.
Yeah.
With the EuroBSDCon conference. Cool. So a couple more questions. Chip, I think Chip, are you on the chat? Do you want to ask the question? Maybe. Yeah. Chip, sure. Yeah, go ahead and unmute and ask your question.
Yeah, I was at the OpenZFS conference last fall, and one of the things I caught was that FreeNAS seems to get patches before FreeBSD. I'm curious on if that's correct and what's the logic behind that and how do things move around in BSD.
Sure. So I can't say whether that's true or not because I don't really have my pulse directly on FreeNAS. But the way that things happen in any type of open source community is whoever does the work, makes that work happen. And Jin Lee, who works on the FreeNAS project for IX, is one of the major integrators of changes that come from Lumos down into FreeBSD. And maybe I can add a little bit more color to how that works, just from my own experience in trying to get work that's been developed at SpectraLogic back into the open source community. Oftentimes when you create a change for a particular environment, say it's FreeNAS or Spectra has Spectra BSD, which is our platform, there are certain requirements that the open source community may have that don't apply to your product, which allow you to increase the speed at which you can provide a solution for a particular problem. But it's a partial solution, right? ZFS is kind of unique in the sense that the features work across the board. So if you have deduplication or you're using snapshots and replication and all the different features, RAID Z versus mirror, the underlying goal is that all of the features apply everywhere. That there are no surprises, no hidden gaps. And so when you go and develop a product, though, you don't necessarily have to fill all those gaps. You're balancing time to market and satisfying a customer requirement or a customer escalation, right? A customer's down. So I think that's the reason why you'll see different features not quite available everywhere. The one that I've been working on for 2 years, the asynchronous read, modify, write fault handling for ZFS, yeah, it's frustrating to me that it's not up in the tree yet, but when you go and do the work to get it there, you realize that the initial work really wasn't complete enough or wasn't to the level that the open source community expects. So having to go through that process provides value to the open source community in terms of increasing the performance or the quality of the work that makes it up there, but it does incur a delay. And so when we talk about how to increase the rate of innovation in ZFS and things like that, I think we can do that by explaining to the community the work that needs to happen in order to take something that is a feature in one of the offshoots or one of the commercial products that uses ZFS and to get it into the community and try to figure out how to share that load or increase the number of people who are willing to do that work.
Yeah, and Alan had a good point on IRC, just saying that when the code gets into particular repos versus when it ships can be two different things, right? So it may be that a given feature arrives in FreeBSD source code and FreeNAS source code at essentially the same time, but FreeNAS is shipping more often. Maybe they're shipping a new release every month versus FreeBSD only typically ships every 6 months or so. So it depends on if you're looking at a release product versus the source tree. FreeBSD, obviously you can also download the current code and compile it yourself and run it. But if you're running a release branch, then that's going to have had more testing applied and also be a little bit further behind in terms of you're not running on the bleeding edge.
So I wonder if, Matt, you have any color to add on. Lumos typically does not have branches. So some of the features that we talk about, we'll see them in slides, or maybe they'll show up somewhere on GitHub. What should we do about that so that people can see the work and perhaps participate in polishing it to get it into the main tree?
Yeah, that's a good question. So Lumos has a little bit of a different release model than FreeBSD in that there is no release model. Essentially, Lumos is like a source code repository, and the idea is that all the code in there is production quality all the time. That's true to varying degrees, but that's the goal. And then there's no like Lumos product, right? Just kind of like there's no Linux product. You can kind of think of it kind of by analogy with that. Like there's the Linux kernel, but the Linux kernel by itself doesn't really do anything. It has to be part of a distribution. So Lumos is the same way, where different distributions, like for example OmniOS, would take the Lumos kernel and surrounding library core code and put that into their releases. So they actually do releases pretty often. I think they do like bloody releases, I think every 2 weeks. So you can run very up-to-date code from Lumos on there. And then they do support, and so you can get long-term supported releases that I don't know, those might only be updated once a year or something. So I would say in terms of getting more people involved with polishing stuff, I would say one is like all the stuff that I do, at least I put up for review on review board and send out email to the developer at open-zfs.org mailing list. So I definitely would love to see more people participating there and saying, hey, your code sucks, or you didn't, what about this feature? How does it interact with that? Personally, I'd love to see that. Okay. Sorry, Andre. The Google Hangouts only actually supports like 9 callers, so you can watch on the YouTube and give us your questions on IRC. Sorry, that was a little note from somebody on the IRC saying that there's too many callers already on the Google Plus Hangout. Yeah, so I think that kind of concludes like what I'd love to see people participating more in code reviews, and even like maybe sometimes we don't hit that quality bar in Lumos, and getting follow-up patches. People see, hey, actually that didn't work. Here's how to fix it. We'll try to get that patch in as soon as possible.
And to kind of add to that, I think it also, as people find like different features sitting out on like GitHubs, from different companies or community members, that's a great way for like somebody who just kind of wants to get started to like contribute. They could take one of these things and actually start kind of polishing it up, and without really having to know a lot of the details of what its initial intent was, they can actually get it working and compiled and working, testing on different versions of or distros of ZFS, and then put those things up for review so they can get integrated into the actual Lumos tree.
Yeah.
That would be great.
Absolutely. Like there's tons of patches out there that are like that have been out there for a long time, years. I actually just picked up one that was the copyright on it is 2013. And I'm working on integrating it into our Delphix product and then into Lumos. But there's certainly a number of those, and if anybody has the initiative to do that, I'm happy to send you some links to other outstanding reviews / code that people have sent out, but just haven't quite gotten it over the finish line.
And Justin, I had a question.
Sure.
As you guys have been at Spectra, have been looking at like petabyte scale, and the storage market and technology continues to evolve, what types of problems have you guys encountered with ZFS and kind of a changing drive manufacturers, increasing in flash technologies? What types of things do you guys encounter that seem to be obstacles as technology continues to change?
Right. So I can talk about that in terms of near-term things and maybe a longer-term outlook. Our current focus is mostly about correctness and performance. So we ran into some problems with things like sparing and a couple other minor things inside ZFS that, again, is in a patch set that's not really complete enough to push upstream, but hopefully we'll get there. On the performance side, I think that we've been surprised that the performance isn't better than it is in some cases. In our case, the The objects are typically large. We're doing large sequential writes, large sequential reads, and especially in the RAID Z transform, we don't think that we're getting the performance that we should be able to get out of that. And I think we narrowed down some places or some reasons why that is the case, and they're all correctable. It's just a matter of finding the time and doing the work. In the medium term, the push to continue to have spinning disks be cheaper than flash, because flash has been coming down in price, has led the storage industry to really look at this shingled magnetic recording scheme. So there's kind of a technology gap that's happening right now. The spinning drives have been using PMR, perpendicular magnetic recording, for 10 years now, 12 years, something like that. And they're coming to the end of the ability to increase the density of the media in that space. The follow-on technologies, heat-assisted magnetic recording and bit-patterned media, those are multiple years away. We might see something at the tail end of 2016, but it's probably 2017 before we see HAMR, and we don't really know when bit-patterned media is going to become available. So to continue the historic doubling of capacity every 2 years that we've seen in the spinning disk market, they're really looking at shingled magnetic recording. And you can think of shingled magnetic recording as laying down tracks the same way that you would lay down shingles on a roof. So in PMR, perpendicular magnetic recording, you can read tracks that are narrower than the tracks that you can write. So they take that bit of that part of the technology and they say, well, how can we narrow the tracks that we write? The way that we narrow them is by partially overwriting them with the next track. So you can think of it in terms of logical or block addresses. As you're writing data, you can keep on writing in ascending order, but if you want to go back and rewrite something that you've already written, well, then you've got to mess up your shingles, right? It's just like on a roof. You have a leak under one shingle somewhere. You got to carefully do something, right? You have to have a roofer there that carefully lifts up the adjoining shingles and shoehorns something in there, and there's quite a bit of expense, right, to do that. So we already are seeing these drives hit the market, and because they do not allow arbitrary overwrite of existing data, they're being priced very competitively to try to entice the rest of the storage market to adjust to the way that these drives work so they can be used. And so typically you see like a 10 to 1, order of magnitude difference between the cost of flash and spinning drives. And they're actually exceeding that with some of these drives that are coming out, like Seagate's new 8 terabyte archive drive, which uses this SMR technology. Right now, SMR gives you about a 20% increase in density at the cost of kind of complicated algorithms to be able to reclaim space and defragment free space and things like that. But the trajectory shows that by 2020, 65% of their storage improvement or density improvement from non-shingled to shingled, I mean, that's a pretty huge difference, right? It's like Hitachi has a roadmap slide somewhere that shows a 23 terabyte spinning drive with SMR and I think a 14 terabyte non-SMR drive. So for these large archives where the data is mostly at rest, the SMR stuff, it's here. It's going to be something that we have to adapt to. All of the major players are adopting it, and they're even talking about pushing it into their enterprise class storage. One place that you can see this right now is if you get, say, a Hitachi 8 terabyte helium drive, an HE8, they actually use the same technology that they use for shingled magnetic recording to deal with this inability to overwrite data to accelerate random writes. So on the outer tracks of that particular drive are zones that are reserved for the firmware, and they use a log structured system to take random writes and make them look sequential. And then sometime in the background they push them to the main store. Now on that drive, the main store is a traditional store. You can overwrite sectors as you will, but because they already had this technology that they were developing for SMR drives, they said, well, gosh, we can make random writes way faster on these slower spinning drives. So the technology is going to be there whether we like it or not. So what does that mean for ZFS? I think it means trying to figure out how we can get around the difficulty that ZFS has in moving data. And that's a little bit more further out. In the near term, we have to just understand the algorithms that these drives are using in order to emulate the ability to overwrite data wherever it is. And the way they do that right now is they will perturb a ZFS zone. They will write into the middle of not a ZFS, but an SMR zone. They will write into the middle of it. And then when they get to a point where the host stops providing data, they do that like a track before. So when you write in the middle of an SMR zone, you basically invalidate about a track's worth of existing data above the place where you're writing. So they basically will take a stream of sequential writes, and they'll say, oh, look, you've given me at least a track's worth, or 2 tracks worth, or 3 tracks worth of data. I will write those in place, and then I'll take the area that would have been interfered with, and I will push it over to this private drive space area to eventually be pushed into the main store when garbage collection and free space reclamation can occur. So that's probably a very confused explanation of how SMR works and the complications of it. But I think in the near term, what we'll end up doing inside ZFS, or at least the things that Spectre is looking at, are making sure that we write things in ascending order. SMR drives appreciate that. Perhaps making sure that the way that we account for free space aligns with the zones that are in an SMR drive. And then also looking at ways that we can aggregate data better as we write it and make sure that it's in complete order so that the drive can see that we're writing more than a track at a time, and it can avoid what's effectively a double write penalty on these drives.
Cool. Linda, I guess first I should ask Alan. I know you had you wanted to talk about SMR stuff. Did Justin address the things you want to talk about SMR? Or did you have any follow-ups?
I think he covered most of it. It was just wondering, is there anything special we can do in ZFS to be more compatible with SMR? Like in most cases, ZFS doesn't overwrite anything in place, so really the only parts of ZFS that get overwritten in place are the labels for the ring for the Uber block, right? So are there anything we can do to manage SMR and make ZFS work with it, kind of play nice with it?
I had a similar sort of question. Sorry for jumping in. We noticed, a couple of us were looking at SMR and how it relates to ZFS, and we concluded that the hard part isn't actually, say, the labels and that stuff, but the thing that makes ZFS awesome, repair and that sort of that self-healing, which can cause a lot of random I/O. So anyway, just a few more.
Yeah, I think that when people think of ZFS, they're thinking, gosh, it's a copy on write file system, and so you don't really overwrite in place and things like that. But you got to free blocks eventually, right? And as you're extending a file, the metadata for it changes. Large swaths of metadata change as you extend a file, even. At least on the leading edge of the tree, you can think of going all the way back up to the root of the file system. So you leave in place, this peppering of free space that's in these shingled zones that has to somehow be reclaimed. And so I think in the near term, if we're smart about tracking the fragmentation of these zones so that we know when it makes sense to try to have the drive or re-access them so the drive will do cleaning at that point, that's one avenue. Also making sure that maybe we classify data in terms of its size and its expected longevity so that we end up freeing stuff, things that get freed rapidly, maybe at the top of the file system that are changing all the time, they might be placed someplace different than the metadata that's related to a file object that a user laid down. But I think longer term, if we really want to get the best performance out of these systems and we want to have access to the cheapest drives, those are the drives that have no emulation for direct access and single sector overwrite, we'll have to do things at the lower levels of ZFS to be able to deal with that. The strength that ZFS has in this area that a lot of other file systems don't is that it really does combine, it's not just a file system, right? I mean, calling it the zettabyte file system, I think, is modesty, I think, by the people who created ZFS, because you do have the RAID transforms, you do have the volume management. All of those things are combined into one software stack so that when you encounter a problem like SMR, you can basically look at the whole thing and say, how do we solve this? What's the right way to solve this? I don't have to worry about an underlying volume manager changing the geometry out from under me. ZFS controls the geometry, controls all the free space management. And so whether it's SMR or another technology that hasn't been talked about are these variable capacity drives, where depending on the yield in the factory that day, you might get an 8 terabyte drive or an 8.5 terabyte drive or a 10 terabyte drive. I think that we have, it's going to be hard, don't get me wrong, it's going to be hard, but we have tremendous flexibility because of the nature of this software stack to be able to do things with that technology that other people will have even more difficulty dealing with.
Cool, thanks. And I think, Joseph, to address your kind of specific question about Reese Overruns SMR, I think I totally agree that that could be really bad because Reese Over, it goes kind of in logical file offset order, right? It's like kind of go through this file, then go through the next file, and those blocks could be scattered all over the disk. We probably, to make that really work well, we would probably need to do something like sequential resilver, which would, which we've been thinking about for a long time. It would also be tremendously helpful for things like RAID Z, where you have maybe a really wide RAID Z. You have, even today, like dozens of terabytes in one RAID Z group. Resilvering that by doing random IOPS takes like essentially forever. So, one of the ideas that we've had floating around for a while is to do sequential resilver by essentially like reading in all of the block pointers, sorting them by the disk offsets, and then doing the resilver ordered by disk offsets. You probably wouldn't be able to literally read all of the block pointers, but you probably, because you don't have enough memory, but you could like essentially scan all, read all the metadata, bring in, all the block pointers from, offset 0 to, 100 gigabytes, however much can fit in memory, resilver that, then scan all the block pointers again, find all the ones that are in the next, chunk of 100 gigabytes, then resilver those in order. Even though that would involve, reading the metadata multiple times, it still might be overall much faster than, doing the random IOPS, even ignoring SMR, even just on these really wide RAID Z groups that people use.
And there are other alternatives there, right? So if you know that, for instance, the drive is a brand new drive, that it's not like you have to go through, that you're going to do a really small resilver. You can look at the free space maps, and you can use the free space maps to be able to do something that doesn't require you to go through all the metadata, and just do a full clone.
So that's true if you're using mirroring. So if you're using mirroring, then you could go through the space maps and find what parts are allocated, and then just copy just that data in order.
But for RAID Z, the space map's different on that leap EDEV. So
yeah, for RAID Z, the problem actually with RAID Z is that the space map essentially is talking about the whole RAID Z group as a whole, with offsets essentially going round robin. So like offset 1 is on block 1, offset 2 is on disk 2, offset 3 is on disk 4, and then back to disk 1. So the problem is that given the space map, we don't know where blocks actually begin and end, and so we don't know where the parity is versus the data of each block. This is an issue that comes into device removal as well, which is why it's right on the top of my head. So changing gears a little bit, Linda, you had a question about, actually, maybe not changing gears that much, about scrub and resilver. I don't think I can unmute you, but you can
Hello?
unmute. There you go.
Okay. I do a lot with the FreeBSD, and there's a couple throttles in there, or they call them delays, the scrub and resilver delays. I'm really intrigued by those. I think those are really cool. Is anybody working on something like that or is it even possible to do at a data set level? I mean, that would be, architecturally, that would be so cool to be able to set some sort of prioritization at a data set, right? And say, throw a little bit of delay into the IOs for this data set versus this data set. But I really don't even know how that works in the FreeBSD, the delays that they have on scrub and resilver. I was kind of hoping, Justin.
Yeah, so the current hooks that you see inside FreeBSD, I think, are a little outdated. And maybe George is a better person to talk a little bit about how changes in the underlying I/O scheduler have impacted scrub and resilver. Because the way that it has worked historically has been kind of like as a hammer. Like, I'm consuming too much bandwidth, so I should go away for a while. And I think that we have better tools now to be able to do that throttling down in the I/O scheduler at the bottom of the stack.
Yeah, as a matter of fact, for a hackathon project, and I can't remember which one, I started some work in this area that actually removed those throttles to allow the I/O scheduler to actually do more of the work, and in some cases do some of what we were talking about earlier about trying to make this more sequential. The next step of this project was, or this hackathon work was, to actually allow us to defer allocating memory so we could even issue, thousands of IOs and not even consume memory until you actually need to do the reads. Most of that work is done. But I think, Linda, what you're looking at, correct me if I'm wrong, is you're kind of wanting almost like a quality of service per data set, which is something similar to what the folks at Joyent had implemented for zones. They have kind of a throttle on a per zone basis, so it's not as granular as data set, but allows you to kind of give more shares to some zone over another one. That work, I think, is out. It's another one of those that, like Patches, that's probably sitting out on GitHub somewhere. That just needs to be pushed over the finish line and could probably be enhanced or made more generic to actually work on a data set level across ZFS. Kind of take those concepts and just make them generic across ZFS.
That's fantastic.
Cool. So I don't.
Can you hear me? Am I still asking questions?
Yeah. Sure. Go ahead, Linda.
I had one more on, is anybody working on, or are there, now that I know that the project's out there, I may actually go stick my fingers in it. But another project that I'm looking at, I've been architecting a lot of systems around like video editing or real large files, and kind of wanting to take cache drives to kind of that next level of maybe a full SSD pool that's replicated back to a spinning disk pool, but leave something on the primary pool to the file handle, the metadata, something out there. I've been doing it really unelegantly right now with a find and a move, and then a symlink back in. But is there anybody out there working on anything more elegant around like tiering, being able to take hot files and keep them on faster disk and move stuff back? So
there are a couple things that I'm aware of that are not, I think, generally available. There's not necessarily for hot data, but for tiering. There's some work that Panzura has done using the additional block pointers that ZFS allows you to optionally keep for data to be able to reference different locations for that data. One location might be in a local SSD, another one might be in the cloud, another one might be in some corporate office somewhere. So that's the Panzura thing. I believe those changes are fairly invasive to ZFS and may not work across all the different features. So I don't know if it works across snapshots or deduplication or whether you have RAID 0 mirroring and things like that. I'm also aware of some work that Nexenta has done that allows you to shunt metadata for a pool to a different tier. But I'm not aware of anybody who's doing things like being able to, based on use, hit rate, things like that, to be able to migrate data between tiers. And that comes down to, the similar areas where, like, SMR is challenging, or free space defragmentation, or file defragmentation is difficult for ZFS. And that is that ZFS tries really hard to make sure that when you go to access a piece of data, that it is exactly the data that you want. And the way it does that is by these hierarchical checksums, which means that when you move something, well, that's the same thing as invalidating that data, right? You have to update, find and update all the places in the file system where that data is referenced in order to be able to move it. So you're not alone in wanting those features. I've heard that several times. I've heard that at SpectraLogic as well. But I don't know anybody who has devoted the resources to try to solve that problem right now.
I would like to chime in. You mentioned the Nexenta work.
Mm-hmm.
I work at Nexenta, so I know a little bit about that. There, like on several occasions, you said companies implement what they need, and whatever they don't need, they skip because it's a resource question. You can get the Nexenta code on GitHub, and that gets you the tiering to shunt the metadata off to the side to a special device. There is also code for a write cache, which is sort of a write back cache, and in the background the data gets moved to the slower devices. There is enough code that it does work. I don't actually know how well it works. The code is out there. That's what I wanted to say. If you can make use of it, good luck.
Do you know if Nexenta is using any of those features in their actually supported products?
I don't know which ones are actually enabled in the currently shipping product. I've been around at Nexenta for only a year. And I've been focusing on the latest and greatest. And of course, we do have some changes that we want to commit. What was the other thing I was going to say about this? Your mileage may vary. I'll remember and speak up again.
Cool. Well, I think we're closing in on about 15 minutes left of the office hour. I wanted to get this one in for you, Justin. What feature or enhancement of ZFS are you most looking forward to that is kind of in the pipe that you know of? And then what do you think is most sorely lacking in ZFS that you think someone, possibly yourself, possibly someone else, should go implement?
Yeah, I think, what am I looking forward to? The resumable send and receive. We've definitely, so at Spectra we have talked about enabling replication for our customers for some time, and the problem that we have is we have existing customers that want this, and they have terabytes or petabytes worth of data already set up, and they have a lossy link going somewhere else, and so you basically tell the customer, don't sneeze for 2 weeks, right? So I think I'm definitely looking forward to that, and I think the solution to it is really elegant, so that'll be really cool. As far as most sorely lacked feature, I think it really depends on the people that you ask. I mean, some people will say things like, gosh, I wish that...
Like, what would you personally
what would I love to see?
Yeah.
I would love to see a clustered ZFS of some sort, and most of that's from my FreeBSD perspective, where we don't really have a good clustered solution on FreeBSD, one that is liberally licensed and such. And I would love to work on something like that. I think there are some other things that, at least in the FreeBSD community, smaller features that people are really looking forward to. Like at SpectraLogic, we have ZFSD, which is a fault management daemon for ZFS. My personal opinion about ZFSD, and I can say this because I wrote most of it, is that it's a stopgap solution. But people still need those features, right? On FreeBSD, we don't have the full fault management framework that you see on Lumos and on some other operating systems. And so ZFSD was a way to at least handle the faults that the majority of people using ZFS would encounter. There are a few things, just like, as we talked about, or has come up several times during this session, there's several things about ZFSD and the things that it requires in the kernel that have prevented it from being upstreamed. But hopefully sometime this year, knock on wood, we'll get that up there. There have been times that it would have been really nice, or it would be really nice to have a pathway to do things like free space defragmentation or object defragmentation. I think there's still a lot of low-hanging fruit in terms of initial data placement, that makes more sense to focus on initial data placement in ZFS and allocating more resources to the allocation algorithms in ZFS first. So I don't think that's as pressing as some of the other things. But and then there's this fear that I have about SMR. I think that will get worked on. I think there are enough people that are similarly scared about the performance drop that you get if you don't do anything with SMR drives, that some work will happen there.
So quick kind of follow-up question on SMR. All file systems are kind of evaluated in comparison to the best alternative. So do you see like the competition such as it is in the file system space? Also, very concerned about SMR and doing any work in there. Do you know of any other file systems that are like working on optimizing stuff for SMR, or any work in that area?
Yeah, the only work that I'm aware of is what's been done by the drive vendors. And so you'll see patches out there for like ext4, but they will, acknowledge the fact that if you run ext4 on top of any type of volume manager, it doesn't work. So I don't know. I think that most of the first place that you're going to see real SMR support in production, apart from running on devices that emulate a normal disk drive, is going to be at the cloud vendors, the Googles, the Facebooks, things like that, where they're basically just putting resources into, okay, if you started today and you wanted to do an object store, you don't care about snapshots, you don't care about replication, you don't care about any of these other things, and you wanted to do it on these cheap drives, how would you do it? And so I think you're going to see papers, this year, next year, about how people have done object stores on top of SMR. But if you really want to take advantage of the compelling features that ZFS has, I don't know that there is a competitor right now that is as mature and really as well equipped to be able to deal with some of these challenges. And for me, it's the maturity part. Being able to take a product idea and develop it on top of ZFS and not ever lose any customer data. I mean, you can't do that with the competitors. They're just not at that point yet. And so long as a community, we continue to develop our stuff with that level of rigor, I think that people won't be able to catch up. I mean, I don't know if you have an estimate for the number of man years that went into ZFS, but it's a large number. And it's hard to think of starting from scratch and getting the same features and the same reliability with something else.
Yeah, I mean, definitely more than 100 engineer years.
Yep.
And so it sounds like this is really an area that ZFS has the opportunity to pull ahead of other general purpose file systems. Probably the Googles and Facebooks of the world are not going to be making general purpose file systems with snapshots and clones and all that stuff. They're going to, any of those kind of features that they need, they're going to implement at some way higher level in the stack.
Yep.
It's actually my understanding that the Linux file system community sort of feels indifferent about SMR, as in sort of well, it sounds like a good idea, but we don't see a compelling use for general purpose storage, aside from just it's cheaper. But it makes everything harder, so let's see if this is just a fad or if it actually is around to stay. So let's just sit back and wait a little while and see what develops.
I think that's wishful thinking. if you look at the cost curves and the capacity density curves, they can't, they being the disk industry, they can't keep their current linear march without SMR. And so we even hear that the enterprise class drives, the 10K and the 15K RPM drives, are going to bring this technology in. So you may bet on flash totally displacing spinning media in these tiers, perhaps, if it gets cheap enough. But we seem to be a society that generates so much data that flash just isn't the solution for everything. It just can't be. You can't scale it. So.
And Matt, real quick, just to follow up on the file system SMR question. I ran across this the other day, and I have not had a chance to dig into it, but there is apparently somebody who's working on an SMR-specific file system called High SMRFS. I think it's probably more research than anything else, but there are people that are looking at this as a way to address issues that SMR is going to bring to the surface.
Cool. So I wanted to get in one last question for you. So I think, Justin, you've attended all of the OpenZFS developer summits, all 2 or 3 that we've had so far?
Continental ones. I think there have been some in Europe.
Yeah, that's true. We had that one in Europe and another one coming up in Europe. So I wanted to ask you, what would you like to see more of in the next OpenZFS Developer Summit, which hopefully, we don't have a firm date yet, but we're looking at October 2015, which will be very, very close to the 10-year anniversary of when OpenZFS was, or when ZFS was first open sourced by Sun Microsystems.
Wow.
So hopefully we'll be able to have a little celebration for that. But wanted to get your take on what you'd like to see more of or different at the next Developer Summit.
Yeah. So I think that my thoughts on this kind of mirror what FreeBSD is looking at doing for some of its developer summits. And so historically, there's been presentations and discussion and things like that, and then having a second day where we do a hackathon. I would really like to encourage people to think about the projects and what progress they can make in person that they can't make otherwise, and try to push those ideas forward and get slots into the OpenZFS, either the hackathon or maybe even a working session or open discussion session in the main day of the conference, because it really is that face-to-face time where you have access to a whiteboard and free-ranging discussions and things like that, where you can make, in half an hour, you can make more progress than you can make in a month or two. So, I mean, historically, the hackathon stuff has been in terms of, what can you mostly get done in one day? But even when you talk about things like channel programs, right? That's a multi-year effort and things like that. Having the people in the same room to talk about those kinds of things and how to push it forward or solve the problems that the individuals working on them haven't been able to solve, that's the real value that I get out of it. So being able to promote more of that and organize more of it in advance, I think you'll get perhaps even better attendance if some of the stuff that's on the hackathon day is talked about and understood before.
So do some kind of like design sessions or something during the main day.
Yeah, and have maybe even open the design discussion for some of those things before the conference, so that people come prepared. Right, because some of the stuff, I mean, I'm just speaking from my own experience in trying to come up to speed with how ZFS works. There's a large learning curve, and so to be able to participate in an area of the file system that I haven't really spent much time in, I want to go read that code in advance and be able to participate, not just to be able to sit there and soak up, which is also good, right? Learn from all these other people. That's part of the reason why you're there. But I think to make the best use of that time, it's really to prepare for it.
Cool. So I think we're just about out of time with Justin for I don't know why we call them office hours. I guess it's 1 hour at a time. It's 1 hour, but there's several of these hours. Like we had one last year, and now we're having an office hour this year, so there are office hours.
Don't feel too bad. I had professors in college who did the same thing.
maybe this is the OpenZFS office hour with Justin Gibbs. I'll
there you
do
go.
that after the fact, so nobody will know that I made that mistake.
Watch out, pretty soon you'll have like these great graphics and things like that zoom in and promotional materials. And...
Unfortunately, my specialty is not motion graphics.
Yes.
Cool. Well, thanks a lot, Justin, and thank you again, Linda, for organizing this. Hopefully, with your help, we will have these on a more frequent than annual basis. I think originally the goal was quarterly. I think that's still a good goal. So hopefully, look for something coming out next quarter with a different special host/guest. Thanks, everyone.
It was great. It was a lot of fun. Thanks.